Hello Next.js Conf. My name is Jon Meyers and I'm a developer advocate from Supabase. At Supabase, we love open source. We do what we can to support open source because we are open source. And so we wanted to take the time today to talk a little bit about what's under the hood with a Supabase project and highlight some of the awesome open source projects that actually make that possible. Koppel is going to take us through Postgres. That's a REST API layer that sits on top of a Postgres database, and is going to cover auth in Supabase using Netlify's GoTrue library. Wembo takes us through how Supabase implements realtime using Elixir and WebSockets. Inian is going to explain how Kong is used as a gateway and a little bit about file storage. Johnny is going to take us through some of the UI tools that make up the dashboard. And finally, we want to showcase an awesome community project called Slip, which is a course marketing platform built with Next.js and Supabase. Over to you, Koppel.
Hey everyone, I'm Koppel, CEO at Supabase. Today I'm talking about one of my favorite open source projects, Postgres. There's Postgres with a T, not PostgreSQL the database. Postgres provides an auto-generated API on top of your PostgreSQL database. And instead of explaining why I love Postgres so much, I thought I'd show you with a demo. I've started a Postgres database using Supabase. I'm building a Slack clone, so I've added some tables which you're probably familiar with. A messages table which stores all the user messages, and a channels table with the default public and random channels already populated. For this demo, I'm also adding a new table called leaderboard where I can store both the user ID and the total number of messages each user has sent. Now let's jump into the auto-generated documentation for our demo. As you can see, the docs are populated with all the tables we just created, including the leaderboard which we created live in this demo. The API is extremely powerful. You can use it to fetch individual columns or all the columns. You can add filters to only return a subset of rows, and you can even build nested queries just like GraphQL. Let's jump into the channels documentation and copy one of the requests to see how it works. First, I'm going to select everything in the channels table. I can use the JavaScript libraries, but for this demo, I'm going to make the request directly using curl, and I'm going to use an anonymous user. After I've copied the code, I can run the request, and it will return both the public and the random channels. Now let's modify the request to return the messages as well. Postgres automatically detects a relationship between these tables, so when I run the query again, I now receive the messages in each channel. Postgres is an extremely thin layer on top of PostgreSQL, which means we can use many of the features of PostgreSQL inside the API. For example, our API doesn't seem very secure right now since it's returning all the messages for our anonymous users. Let's change that by turning on PostgreSQL row-level security for our messages table. After we've done that, we can run our query again, and voila, the API is no longer returning data for our anonymous users. In this demo, I just scratched the surface of what Postgres can do. Postgres is a connectionless API, so you can use it with any Jamstack or serverless framework, including, of course, Next.js and Vercel.
Hi, I'm Ant, co-founder and CTO at Supabase. Supabase Auth is two things. First, it's an authentication API, which you can use to sign up your users using their email, mobile phone, or one of a long list of OAuth providers, such as Google, Twitter, Apple, or Discord. Unlike other auth providers, the user data is stored inside your database, so you have full control over it at all times, which is great for privacy and awesome for things like GDPR compliance. Logging someone into Supabase is as simple as supabase.auth.signin and then pass the email and password directly from the client. And account recovery for forgotten passwords is all included. Supabase even manages the transactional emails, which of course are also fully customizable. The second thing that Supabase Auth is an authorization layer. You can write access policies in plain old SQL, instructing your backend which data a given user should or should not be able to access. And because it's just SQL, your rules can be as simple or as complex as you like. You can implement admin or moderator accounts using role-based access control, or you can do more advanced things like limit the delete access according to the time of day, or geolocation, or whether the user has a certain email domain or mobile country code prefix. Another cool thing made possible by our auth and file storage integration is that because we store the entire object tree in your database, you can write these row-level policies to control access to all of your folders, files, and buckets. If you want a bucket that's available to the public and another storage bucket that's only available to pro users, you can do that, and it's easy, and you can do it all from the Supabase dashboard. As with everything we do, Supabase Auth is also fully open source. So if you want to add some new functionality, let's say a new OAuth provider, or just audit the code yourself, then it's all available on GitHub. I hope you have fun playing with Supabase Auth.
Hi, I'm Wembo, and I'm a software engineer at Supabase. Supabase Realtime consists of a server and client working together to send Postgres database changes to users in real time. Realtime server connects to the database and subscribes to insert, update, and delete changes via Postgres logical replication and broadcasts those changes via WebSockets. We decided to build the server with the Elixir programming language and Phoenix web framework for a number of reasons. We chose Elixir because it enables massive concurrency, fault tolerance, and isolation by utilizing the Erlang virtual machine, which has been battle tested over its 30-year existence. We chose Phoenix because it takes advantage of the best of Elixir while providing the right abstractions, such as channels, making it easier to work with WebSockets ranging from thousands to millions of connections. All of these features were important to us for the type of highly available and performant real-time server we wanted to offer to developers. And as we continue to scale the real-time server, it gives us peace of mind knowing that apps such as Discord and WhatsApp rely on Elixir and Erlang respectively for their chat infrastructure. Real-time client establishes a WebSocket connection, enabling communication with the real-time server, and receives database changes. Today, there are official Supabase clients, as well as community-maintained ones written in JavaScript, Python, Dart, and C#. I want to quickly demonstrate Supabase Realtime in our Next.js Slack clone that's available on our GitHub. Here are two users, Wembo1 and Wembo2, who are sending messages to each other. Messages are inserted into the database via Postgres API. Then Supabase Realtime will pick up the inserted messages and broadcast them to both users in this channel. Now let's go ahead and take a look at the messages table using the Supabase dashboard. And as we can see, all the messages are present. Next, let's use this dashboard GUI in order to insert a message into the messages table. We can see that the message was broadcast to both users. Finally, let's go ahead and insert a batch of messages in a single database transaction. In this case, there are 4 inserts inside of this transaction. Again, both users will broadcast the messages inside of the transaction. Now, it doesn't matter how you get data into your database, but once it's there, Realtime server will pick up the changes and broadcast them. We're currently working on improving the security of Supabase Realtime by only broadcasting changes to those users who are authorized to receive them according to Postgres row-level security. We'll be releasing this into production very soon. We're also working on providing additional real-time functionality to developers who are interested in building synchronous apps. Thank you, and I hope you have a great time exploring Supabase Realtime.
Hi everyone, I'm Inian from the Supabase team. We use Kong for our open source API gateway. Kong is built on top of Nginx, which is very battle tested and powers a large portion of the internet. And Kong offers a lot more features on top of it, which makes it ideal to use as an API gateway. All our other services like storage, Postgres, Auth are protected by Kong. Apart from authorization and routing, one of the key features that we use Kong for is SSL termination. We use Let's Encrypt to provision our SSL certificates for all projects hosted on Supabase. Let's Encrypt is open source, builds on the Acme protocol, and has provision certificates to more than 260 million websites. Kong is flexible with support for a lot of plugins, and in the future, this would help us implement rate limiting, adding and removing API keys, and Kong has a good foundation for implementing these features. Supabase Storage is an object storage service. You can upload any asset or media file to our service. Storage integrates very well with the rest of the Supabase ecosystem. Storage sits behind Kong, and the metadata for all objects is stored in your own Postgres database. This makes your data very portable. And since we target the S3 API, it makes it very simple to add support for more storage backends like Backblaze, Ali Cloud, and even the Cloudflare's newly launched R2 service. The storage API is built on the Fastify framework. It is one of the fastest web frameworks out there and has a very rich ecosystem around it. Our client library for storage, Storage.js, has a very familiar API. If you have used our client library for Postgres, it follows a very similar syntax to that. We have a profile management example which makes use of storage, and you can deploy quickly to Vercel. That should get you started with Supabase storage, and excited to see what you build with us.
Hi everyone, my name's Johnny. I'm from the Supabase team, and I'd love to talk to you about our dashboard. So our dashboard, for anyone who's familiar with Supabase, you'll know how it looks and how it feels, but you probably have no idea what it's built with. And it's probably no surprise to anyone, we use Next.js. We use Next.js for pretty much all of our websites. We use Vercel as well. So all of our serverless functions are on there. We also use SWR. Also interested in using multi-zones, which we haven't implemented yet, but we're interested in putting all of our Next.js apps together so we can have we can put them on their own URL, I suppose. So like our documentation site could live on /docs, and our dashboard can live on /dashboard, things like that. But what do we use that isn't Vercel based? Like what other open source stuff do we like? So one of them is MobX. MobX we use for state management. I think usually you use one store, like one main store. But we actually use several. So we actually have a MobX store for kind of everything. So we try and replicate what we have locally. To give an example, if we were using Supabase Postgres meta, we would fetch tables from it, which would be the metadata for tables for your Postgres database. We bring it down, and then we would actually save it in a MobX store called tables. And that would be accessible anywhere in our application, along with other stuff like maybe tables, projects, schema, and we can list them all, get the length of them, or whatever we want. It can be done anywhere in the app. It's pretty handy. Another thing that we're quite interested in doing is dog fooding our own Supabase realtime. So if there's any changes, so for instance, someone adds a new table, that would come down Supabase realtime, and then we could add that change into the MobX store automatically, and then all of a sudden your client is already up to date with the change that's happened remotely. Really cool stuff. Moving on, our UI components. So we can't talk about the dashboard without talking about visually how we put it together. So we're using Radix. Anyone who's been working on front end would have probably heard of it. It's an accessibility focused design system. It means that kind of the components in it, or primitives as they call it, handle all of the kind of accessibility needs for you. So things like keyboard control, Arial labels, it's all done for you. And all you have to do then is style it, or like structure it the way that you want, add the CSS you want, and then you have fully functional components that look the way that you want. But the way that we style it was actually a singular CSS file for each component, but we're actually moving towards using Tailwind because we use Tailwind everywhere. Everyone in the Supabase team loves using Tailwind, so like why did we stop using it for the UI library? So we're actually working on a theme provider that kind of wraps around the whole app, and then it would inject the correct Tailwind CSS classes for each component. And you can see here, this is my example of changing the Supabase brand to purple, which I don't think anyone is gonna like at all. But I can keep showing people, and maybe one day Supabase will be a purple brand. For forms, we actually had several different implementations of forms, but one library that we've kind of decided on because it was just easy to use. It was stable and just easy to use. We just liked it. React hook form. So we're kind of like rewriting some of our UI components so it works well with React form. So that's pretty cool. And the reason we've actually been working on the React form stuff in the last week or so is actually because we're really trying to open source our dashboard. So everything that you saw before at the beginning, we're going to make that publicly accessible. And it's probably going to live in this repo called Supabase. There will be like a directory called Studio. And we're going to put the dashboard in there. We're going to try and open source as much code as possible. We're working flat out to really pull apart our code. So anything that's kind of infrastructure based, that's to do with billing or to do with our actual like hosting platform, we're trying to like separate. It's been a bit of a big job. We know people have been asking for it, but hopefully soon it will be open sourced. But you heard it here first. Yeah, we're open sourcing it. So thanks for listening, and on to the next speaker. Thanks.
Hey everybody, I'm Kenneth and I'm the founder of Slip. We're a marketplace that makes it easy for expert developers to build and sell interactive programming courses. We were in the most recent summer 2021 YC batch, and we're big fans of Next.js and Supabase. Both of these tools allow us to iterate super fast on our product, and I think they're really amazing tools that help a small team like ours get a lot done really fast. And today I kind of want to tell you specifically how we use these tools and how they help us at Slip. I think a great place to start is kind of the evolution of our tech stack. So initially, I started building Slip when I still had a day job, and I had never used Next.js. I was building it using a Create React app kind of scaffolding, and then I had a traditional front-end, back-end kind of architecture where the front-end was React, the back-end was a fast API server. It's like a Python API server. It's similar to Node. And then I had a hosted Postgres database. The stack worked okay. The main issue I had with that stack was that I felt it was extremely slow to make schema changes to my database. When I made schema changes to my database, there was a lot of kind of boilerplate code that I had to write inside of Fast API. Fast API is a great product and it has a lot of cool like auto-generated stuff for you, but it still felt quite slow to add like new tables to my database and interact with it. So the first thing I did was I switched to using Next.js and I got rid of Fast API. By using Next.js, I was able to move all those calls to the database into the API layer inside of Next.js. So this really sped things up and made things a lot faster as far as like development speed. And when you're a startup that's pre-product market fit, like being able to iterate fast is like one of the biggest things that you can focus on. And so we really kind of focus a lot at Slip about choosing tools that help us iterate as fast as possible and get a lot done. So we switched to Next.js, and that also had the added benefit of kind of like cleaning up the structure of my code and making it like a standard pattern that anyone coming off of the street and working on the project could really easily kind of get their feet wet if they've used Next.js before in the past. So that was actually like a hidden benefit that I didn't think about, but it's been like really great so far. So, as we've had contractors and like employees come on to Slip and work with us, having Next.js and like that standard pattern has actually been really great in getting people up to speed on the code. The next reason why we ended up adding Supabase was initially because I just wanted a better UI for interacting with my database. So if you've ever used like PG Admin or other tools like that, it's really not the best experience. It's like pretty buggy, it's slow, it's unintuitive, and I just thought that the Supabase UI for interacting with your actual database was really nice. And so there's lots of times where we want to go into the database and like get particular information out, and it's just easier to use the UI. And that was the initial reason why we switched to Supabase, was because we just wanted a nicer UI for our actual interacting with our data. The surprising thing was that we ended up finding out Supabase was so much more than just a better hosted Postgres, and it's actually allowed us to ship even faster. So now like we're pretty proficient like Supabase users. We really love the project, and we use multiple things from Supabase to build faster on Slip. So not only do we use the hosted database, but we also use storage and authentication. And with that, it makes it super easy to actually write client-side code to retrieve data, and you can restrict it to users based on row-level policies, which is really awesome. And I think basically with the combination of both of these tools with Supabase and Next.js, like we're able to like ship and iterate on new features like at a pace that would have seemed like crazy to me a year ago. So yeah, I think that, when you're a startup, choosing tools that help you ship faster is a really great way to make sure that you are, interacting with your users and you're building the right things, and that you're just kind of like continually like getting that feedback loop. And Supabase and Next.js really help us do that at Slip. And so yeah, that's me. I'm Kenneth, and I'm the founder of Slip. And hope you guys enjoy the rest of the talk. We're big fans of Supabase, big fans of Next.js, and encourage you guys to check both of those tools out if you want to ship faster.
Thanks, Kenneth. It is super cool to see Next.js and Supabase working so well together. These tools go hand in hand, both built on open source, both cater to the client and the server, both helping to build a better, faster web. And we are very excited to see where people take this in the future. Thanks for your time, and go build some cool stuff.